go again. Okay, so what we'll do is we'll go around the table and share one of the 3 points that you wrote, and then rather than just a round robin of what you said, let's take a moment to either agree, disagree, add on, just using some of those talk moves as we go. So who would like to start, or something that you want to remember?
I'll start. So on page 9, I was surprised when I saw the table that they showed where,
I wrote the same thing down.
yeah, how few kids were able to answer that correctly, and then some of the even younger kids were, more of the younger kids were able to answer correctly than even the older kids. So just to not overlook that misconception if you're in the older grades. And assume that
Sorry, what page are you on?
Page 9.
9.
The table shows correct response
Okay.
by percent, and actually, younger kids are typically more understanding of, they may not have a conception of the equal sign, but they have a better, they can put the correct answer in there more often than middle or third and on up, and that is very surprising. Why do you think that is?
I think possibly one of the things I put is that it's the rules. It talked about making that the kids, they get rules for everything, and as they get older, like in the CGI we mentioned, yes, it's like it all gets all jumbled up and they forget which way to go, which method, because it's not firm. So they're trying to like, oh, is that, oh,
Which piece of the
Which-
algorithm
yeah.
am I gonna
What
grab
am I gonna do
to
with
use
that?
right now? Yeah, I think when they're younger, they have this intuitive sense that math should make sense. And when we come into school and we begin to introduce all these algorithms and procedures, and they're willing to let go of their sense making that they came to school with, because the teacher's like the expert, the teacher knows, and so I'm gonna follow the procedures and the rules. And that's why we have kids who, when it's 13 minus 5, they'll stack 13 and 5, cross out the 1 in the tens, bring it over to the 3, and they've still got 13 minus 5, but the teacher, that's the process I've been taught. They'll do that because they've learned that. They've overgeneralized. They've learned that whenever I'm faced with a subtraction situation and I can't take the smaller or the bigger number away from the smaller number, I must go next door and borrow or regroup or whatever term you want to call it.
yeah.
And so I think you're right. I think they're willing to let go of their sense making and go with a process. Other thoughts around why the older they are, the less accurate they were in that situation?
Well, one of my thoughts was I'm curious how this data would play out in today's world, because this is pre-Common Core, and I'm
It's
just
99.
I'm just wondering,
Good
and I
catch.
actually wrote in here about the Common Core, wondering because it was talking so much about the properties, and I'm really only familiar with 6th grade Common Core, and the only property we deal with is distributive property. And when I say deal with, I just mean specifically for covering that content in that area. So one of my biggest question is where do these properties show up in the Common Core, and how thoroughly do they show up? Because that's what they're really digging at. That was a wondering that I had. So I think that the data would be a little different, because I was actually pretty surprised about the 5th and 6th grade. I think that if we would have done that today, in today's classrooms, I don't think it would be that high. That's just a guess, but
Be interesting to find
because
out.
of the work that's being, the
Right.
purposeful work that is built into the, I don't know, maybe, anyways, that's my 2 cents.
How long has Common Core now been official?
We had 5 years?
My first year as a
Trying
math
to
coach,
think.
and this is I'm ending my 4th year as a math elementary lead. Am I in my 4th? Yeah, I'm ending my 4th year.
No, I'm thinking it's at least
So,
4 or
and
5.
it was full implementation that year. So 2013, 14 school year was full implementation.
Because we really won't know for, you know, technically 13 years from the start, from that kindergarten group.
Yeah, that's the
Yeah.
spiral,
Yeah.
Yeah. So that's a good point though, to notice the date on that.
But even in 6th grade, it would have only have had to spiral without.
Well, and
so.
I don't think there was fidelity when it first started either. With some people, there was
That's
some
true. And plus,
resistance. That first kindergarten group may have not got it.
well, yeah, that's true. I was gonna say, I really was surprised at how deeper my understanding of a Common Core went when we did the proficiency scaling. I think that everybody should have to do that because I was teaching things I shouldn't have been teaching because I thought that's what it wanted me to do, and it wasn't. It wasn't. So that was, eye-opening. But
Right, that unpacking of what the standards really
really mean was super eye-opening.
was, and you aren't the only one to say that. I mean,
Yeah.
people throughout that whole process, though, that year said, oh, I need to change my instruction based on what we talked about in our proficiency scaling work. Because that very thing, the textbook said I'm supposed to be teaching X, Y, and Z right now, but that doesn't line up at all with what Common Core says I'm supposed to be doing. So again, that looking at our materials with a critical eye and deciding.
And I think it's that conceptual piece too, because like even today, I was in the 5th grade classroom and she was teaching division of fractions and she was teaching them to flip and multiply straight across. And I was like, wait a minute, in 6th grade, we're responsible for the conceptual work on that. That should come after that. So.
Yeah, we have a lot of that still going on.
yeah.
Right, but I'm
There
sure
All
that
over
in
the
her
district.
you know what I mean? Like it's just that
Yeah.
that level of understanding. And I did the same thing with percents. Like for 6th grade, I was teaching percent shows up in ratios and rates, and they want it taught as a ratio and rate. But when I saw percent, I just assumed, okay, well I'm going to teach it as the equation. Things.
How to figure
How
out.
to-
Yeah.
Move
Yeah.
that
And after
decimal point.
Yeah, and after we did proficiency scale, I was like, whoops. My life and my kids' lives should be a lot easier around percents because that work will be done in 7th and 8th, and I can just really focus on setting the stage for with the ratio.
And there's still people who are teaching things beyond what the Common Core says that they should be teaching. Because, I've always done it.
Yeah.
This is the way
And
I've
even
always
the
taught
textbook
this, Yeah, the textbook
might even
may
do
say
it.
do it this way. And so, yeah, you're right.
Yeah.
But I would still venture to say that we'd have a larger percentage of kids still wanting to put 12 in that box, because that's what it's been for many, all the years of their schooling. It's always been A plus B equals the answer. And so I would venture to say, even though this was pre-Common Core, we'd still have a large chunk of kids still putting, because the answer comes next. The equal sign means the answer comes next. Either that or like it said in the book, you'll have kids who will extend, or, it's either gonna be 12, 17, or 12 and 17. So it's an interesting thing you could do some inquiry with a 6th grade class or something in 5th or 4th or something and see how
Yeah.
many kids do what they do. I go around, sometimes teachers will ask me to do an assessment on a student. It's not usually the whole class, but there's always that relational thinking, some kind of relational thinking piece that I give them, and very often they don't put the correct number in there. Now granted, these are people that the teacher has some concerns about, but there was a problem I gave, I think I use it with 2nd all the way up through 5th, and it's like 65, well here, let me write it down so you can see it, and Lisa can see it beside I know you're like me, you're not much of an awe.
Here, if you want it, might show better than the line.
But it's like 65 minus 37 plus 36 equals box. And now that's not the same as the relational thinking piece there, but you know, this is one less than this one. There's the relational thinking piece in this. Very often they calculate this and then they add it back, add this back on. And
Instead of just 64.
instead of saying
Yeah.
4. So, again, I think it's, the relational thinking piece is huge, and we want to encourage that in whatever way. So, Kathy, we are doing right now, we've had some writing time, 3 points from the book that we want to talk about right now. Things that, and then we'll go around the table again with things that square with your thinking, or things you agree with, or you've tried before. And then the last round will be something that's still rolling around in your head or you have questions about. So just so you're in on what's going on right now. So we just got done talking about the page 9 in the book, at the table there of the number of kids putting in the incorrect number in the box. So who would like to go?
Points to remember, is that what we're
What's
on?
that?
Are we on?
Yeah, we're
Okay.
still on points to remember, so Isabel just shared her first one thing, what,
I'll go, I can go. And the other thing, it's on page 20, and it's what to avoid, and I see it a lot on graphs, and I mean, you almost have to redo every graph, because they'll have like, each book equals 2. So, you know, they have to read the key that they know when they're counting the books. They don't just count them individually, but they have to count by 2s or they're by 5s or whatever. But that is not a correct use of the equal sign, because a book, how does a book equal 2? So I don't know, that still kind of gets me, and
That's a good point, though. That's a
been-
really good point.
I've been guilty before of doing that exact
that's a
same
good-
thing, but, so now, I mean, like, yeah, I guess you have to write, each book means it's 2 books or something.
yeah.
I don't know how
or
you
you
get
could say
around that.
book, you know, you could use the icon maybe, means, or stands
Or
for
2
books, or
yeah.
something like
Yeah,
that,
that's a
instead of.
good one, stands for.
But you know, I remember we did this and discussed this last year when we did the same book study. And it really opened my eyes to like, oh my gosh, there are a lot of incorrect uses of the equal sign. And it wasn't till I reread this year, this is what my third go around reading this book. This time I was like, well, what's wrong with number 2? So if you're looking on page
I wrote
20, it's like, what's wrong with that? 6 equals 6, or 6 turtles. But they said in the what to avoid, right above that table, and then they go on to talk about it on the top of page 21. And this time, I connected with their saying the equal sign is a relationship between numbers or expressions representing numbers. And now it's like, okay, that's why. I mean, John equals 8 and Marcy equals 9. That one I get, because John's not a number, and he's, you know, he is a certain year old.
Yeah, then say it.
Yeah, and I think we use that as a shortcut sometimes. I know I do it all the time, and now I'm like, oh, should I write it like that, or should I write it out? Even in my own notes to myself, I questioning whether I should write, is that a correct use of the equal sign? So I guess if nothing else, it opens or raises your awareness of it.
I
My
would
only,
love-
go ahead, no, go ahead.
I was gonna say, I would love for, you know, a student some year down the road question a teacher about that, you know, maybe I'll get they'll catch me. But, yeah,
My only problem with that was in the younger grades, we teach them to use manipulatives and things like that are equivalent to the number that they are trying to get at. Like you just said, your unifix cubes, you have an 8 and you have a 3, and that's going to be 11. And so in their mind, they're using these things to represent a number in their head that is equivalent. So that's why I was like, I didn't necessarily agree with 2 and 4 because of the way we kind of could, and it almost is like for the younger kids, I feel like they need the pictures and they need to see the relationship of equivalence in bunnies and turtles, and then we move them from bunnies and turtles to numbers. But I think this is powerful right here, and to not use it would be, I don't know. That's why I had a little problem with that.
That was your
I did.
circle or whatever, got it, that,
Well,
Still-
I didn't put that just
And the
came
collection
from the thing,
bags.
but
Remember we talked about the same thing in kindergarten. I did kindergarten for 8 years, and you do the collection bags, and they count all those items and put a number. And that's exactly what they would do, is then record what was in their bag. So 28 box tops, or 28, squares, or whatever. You throw in red ties, whatever. So I thought that was interesting too. I thought-
especially when you think about numbers, what are numbers really? They're units of something.
Yeah.
And so if it's the units a bunny or a turtle or a unit cube, whatever it is, I just think if we're talking about conceptual learning, that's conceptual learning right there.
Yeah.
As opposed to saying 8 equals 8 or 4 plus 4 equals 8. Just in a child's mind, I feel like they would need that deeper. So I don't know.
well, I hear what you're saying, and I appreciate that. I'm relying on them as the experts when
Yeah.
they say, with
I know,
the equal
it's-
sign should be reserved to show a relation between numbers or expressions representing numbers. A similar concern applies to examples 2 and 4. The number of objects in the collection is 6, but the set itself is not equal to the number 6. A group of 6 children is not equal to another group of 6 children. There is the same number of people in the 2 groups. The groups themselves are not the same, and we should avoid using the equal sign in this way. It's tempting to use the equal sign to represent a series of that's the third example, and that one, please don't, if you ever see someone doing number 3,
Three, yeah.
that run-on equation, please kindly pull them aside and tell them, 20 plus 30 is not equal to 50 plus 7. And 57 plus 8 is not equal to 20 plus 30, because, I mean,
I did have a student call me on that one time, doing that, because I'm just at the board thinking, as my thoughts are going.
It's a
writing it
shortcut.
down.
It's a
Yeah,
shortcut.
yeah. And a student called me on that. Well, I want to get back just a tiny bit more. I really hear what you're saying, and so I'm trying to figure out what would make it better. Like, should they just count the bunnies, and there's a line to put a number, and does it go under the bunnies with another equal sign? I don't.
Yeah, I don't know.
I don't.
What would you
I
use
mean,
instead?
how, because they do have to start.
Well, I think numbers are so abstract for some kids.
Yeah.
Older or
Right.
younger, they're so abstract about what it's really just a unit.
it's a
And-
symbol.
Yeah,
These are just symbols.
symbols, but they represent a unit.
Yeah.
And so that's why I think units can still be equivalent. Like if we're talking about the idea of equivalence, and that equal sign being that the same
Yeah.
as. Like I get that turtles aren't the number 6.
Yeah.
I understand what they were saying, but I just don't know how else you would go about showing the kids, taking them from, basic to that deep level of thinking
Well, I
without
wonder
doing that.
If instead of, I'm just thinking out loud here, but in this number 2 example, if there was a line at the bottom underneath it that said, there are blank turtles, so that they could put in the number
Right.
instead of
The equal.
this is equal to 6, maybe. Again, I think in our adult brains, we go, well, what's,
Yeah.
that's fine. It's just that conceptual piece, what they said, one of the things that I wrote down in as squaring with my thinking, but it's also a question I have, is, when they said on page 2, something about oftentimes their conceptions around the equal sign hinder when they get to algebra. And I'm wondering, how does it hinder their development of algebraic understanding and thinking? And perhaps, reading something into here that's not there, perhaps that's what they're thinking is around these things to avoid, that in some way that might feed into their later misunderstanding around the equal sign, and I don't know. But, I guess we'll have to
Well, I know
continue to wonder.
Yes.
one little piece moving into algebra, like we did in 6th grade, we're responsible for generating equivalent expressions, and you can do that by either factoring in or out common factors, or you can do it by combining like terms. So that's kind of like the domain as they move into middle school. And I know that it's really confusing for the kids to combine like terms, because they get really caught up with x's and y's and then y squareds and x squares and what that really means, that they're different. And I know that one way that I would try and make it conceptual for them was to kind of make it visual. So when we were combining like terms like 3x plus y squared, I would say that y's are yaks and y squares are yiggity yaks, and you can't combine the same. Like when you're combining like terms, they have to be the same. So you can't combine yaks with Xboxes and yickety yaks with regular yaks. They all have to be different, but we can combine yaks and Xboxes and yickety yaks and yickety yaks. And I know that helped a lot of kids by putting like a visual. That's why I
Right.
guess that's why this is kind of confusing to me, because I was equating something, but I guess not. I don't know.
Well,
But that is kind of like where they go in algebra, but I think understanding that they're different.
yeah, I think I think the authors, if I'm going to make some assumptions about what the authors hold near and dear to their hearts, it is that we need to make sure that we are keeping that equal sign as the same as, and that we do all we can to support students thinking around the equal sign, so that when they move into algebra, we do have some algebraic reasoning on Common Core. There's all kinds of operations in algebraic reasoning from 1st grade on. But anyway, I think that if they want to hold that's sacred, and combining like terms, whatever helps them to conceptually understand that on both sides of the equal sign, I think that whatever helps them to get that picture going is fine. I don't think that it would be harmful to them. So we've heard from Isabel and we've heard from Shauna and Amy, right? Or did you tell your?
Well, I didn't, the 3 points that were sticking with me, I kind of took from the introduction and the foreword, as opposed to the thing, they were the basic things, like changing how you teach arithmetic from procedures without understanding to relational thinking and conceptual understanding will allow for students to have success in algebra. And they really were kind of hounding on explaining and justifying their reasoning, and that the properties were a critical foundation for algebra. And that just kept up my wondering of where do the properties show up and how often are they being hit.
I've been in some classrooms, like Brooke Jillian was teaching 1st grade last year and kind of blew me away when her little kids were talking. She said, "And what property is this, boys and girls?" And they said, "Commutative." And I just like, holy mackerel. They know the commutative property? Wow. I don't know that, I don't believe it says anywhere in the standards themselves that this is the year when they learn commutative, this is the year they learn associative, this is the year they learn distributive. I believe that those properties are woven all the time in the mathematics that are covered in the standards. And I think it might be an individual teacher thing to say, boys and girls, this is the commutative property, and have them, to learn that term. I think it's great if they know those terms. I feel more strongly that they need to understand what they're doing as opposed to being able to name it. But yeah, I think that all throughout they're learning those properties. And as we go through the book, we get more into conjectures around those properties and how to support students' learning of those properties. So maybe we'll answer your question as we go along through the book. And I'm right in step with you on what I put down. I had things from the foreword and the introduction as well, and pretty much the same thing you had said. I do want to have you go to the teacher commentary on page Roman numeral 13, XIII. She's a special ed teacher, and some of the things that she said in there really jive well with my thoughts. And she says, like the second sentence, and I think all children can learn with understanding, and there are many children with special needs. These children need more experiences with things that make sense, and they need people to help them make connections so that they can see the big ideas in mathematics. And then she goes on to saying for a lot of these kids, they never get to that understanding because they're so busy practicing procedures, they do not understand. And for children who learn without seeing those big ideas, each day is a brand new thing. That's when they end up piecing together different pieces of algorithms in senseless ways. So that whole teacher commentary really resonated with me. I want us to, algorithms have their place, but not before the conceptual understanding. And I think we, for so many, many years, taught the procedures thinking that was teaching them to understand. And it doesn't. And that's why we have, as our discussion last night, we talked a lot about math trauma and math anxiety, and people to this day, adults, will confess that I'm no good at math, I don't like doing math, I avoid it when I can. I've had people tell me that it's their math anxiety or trauma affected their career choices because they just didn't want to pursue anything that had math because they felt that either traumatized or anxious about it. Yeah. And I admit too, every time I go to a math meeting at the ESD and they do something called Math Delight, and I don't find delight in their Math Delight. Oh no, here comes a Math Delight again, And am I going to measure up? It's that whole, am I going to measure up to these high school algebra teachers or calculus teachers that are sitting in the same room with me and I'm an elementary teacher? And am I going to measure up? And it's that whole idea that I might get called on and I might have the wrong answer, and it just dredges up all of that stuff. And I was a good math student. I mean, I've got good grades all the way through in math. But it's still, there's that sense of, and you were raising your hand, do you have math anxiety?
Yeah, when I first started college, I thought I would go into architecture, landscape architecture, and one of the classes I had to take was college level algebra, the first year algebra college level, and I know the first day he said, okay, if you don't remember this, you're in big trouble, and I didn't remember it. So I eventually just dropped out of that because I thought, I'm not going to make it.
Well, Barb, yes, I remember, I like what you said yesterday, really resonated when you said, when we were talking about the math fear and things, and she says, well, when kids read, and they're reading and they read aloud, and even choral, doesn't matter. You know, they mess up on a word, say it wrong, it's no big, and we go on. But for some reason, we're not trained that way in math.
Right.
And so we develop these math anxieties, you know, and when you're reading with kids, they don't go, oh, I can't, you know, well, some do, but not like the math.
Right.
So that was so true. I kind of thought about that when even that, especially our era was just the answer. That's it.
Mhm.
It wasn't how you got to it, but that fear of not being on that answer, you know, that.
It's we've treated mathematics as a performance subject. We have to perform, and we have to perform accurately.
Correct, yeah.
And it shouldn't be that way. It
No.
should be that there's beautiful mathematical thinking. I mean, Einstein he was a very poor math student all the way through elementary school. So, and he is Einstein. I mean, so we have to change our paradigm around what mathematics is, and it's not the answer, it's the process. And kids can revise their thinking, just like when they mispronounce a word in reading, the next time around, they may mispronounce it again, but we don't traumatize them over mispronouncing that word. We help them, we support them until they can read that word. And that's what we need to do with math, too.
I was helping a third grade teacher that's new to the district this year in Clear Lake, and she was really worried about Problem Solving Friday, where you give the kids a rich task and just let it go. And she was like, they can't do it. I'm really worried about it. I feel the need to anyways. So I said, don't help. Give them the problem. Don't help. You're doing a disservice if you help them. Let them figure it out. And they're not. And I even told her, I was like, they're not going to figure it out, because this is the first time you're doing it, and it's gonna feel like an epic fail, and you're never gonna want to do it again. I promise you that. You're never gonna want to do it again. And I was like, that's the worst thing you can do, because right now your learning target is just thinking. That's all it is. Like it doesn't matter if they get the problem right or wrong. It's allowing them to do it, and it's gonna feel like an epic failure. But if you don't help and you do it, then it's gonna be a success. And the next time they're gonna think, and the next time they're gonna think, and then they're gonna start thinking harder. And then it'll start coming together. And so then I went back, because I had a class while she was doing it. So I went back and I said, how'd it go? And she was like, it was awful. Like, nobody got it. Everybody's hands were in the air. Nobody wanted to do anything with it. They all gave up. And I was like, that's exactly what I told you was going to happen. They're all going to give up. But I said, now next Friday, you're going to not want to do this. And it's the worst thing that you could possibly do to the kids. So you have to go in, you got to do it again, and make them think, because this is not hard math. In fact, K through 6 math is not hard math. Like, human beings can get that math. And
Well, and I think it's so important that the problems be presented in context that kids have access to. And that's if you take nothing away from this book, this is the first one of the series that we're reading. And it's okay that you haven't done this one, because this is, lays the groundwork, but this is kind of a standalone. Anyway, they're by the same authors. But they talk constantly about context and how important context is, because it allows kids access into the problem. When they understand the context, then they have a way to answer the problem. So like the little kindergarten class I was telling them earlier about that said it's more efficient if you power punch and count on. The problem was there are 8 eggs in the they're doing eggs, so their context is all around incubating eggs. There are 8 eggs. I picked 8 eggs out of the chicken coop, and I found 3 more sitting under one of the hens. So how many eggs do I have? Well, the context allows them access into the problem, because they can visualize this basket of 8 eggs, and there's 3 more under this hen, and I'm going to take those and put them in the basket. So it's the context that is so key on problem solving. Another thing I would recommend is to do problem solving more frequently than once a week. I would say do problem solving every day. It's in some form or fashion. And then if you want to do one of those humongous rich tasks than, every once in a while. There's a blog, that I read a blog by Robert Kaplinsky. And you can sign up to read it, get his blog, he'll send you his posts every once in a while, but he just had a posting about, it's called, Why Did You Choose the Problem You Chose? I think I may even have it here on my desktop. Why are you using that problem? There it is, right there. Come on, open up here. I suppose I'm not hooked up. Of course, you guys don't know what I'm talking about because you can't see it out there. But anyway, he said there's 3 main reasons why we choose a problem. And I don't want to butcher it, so I'll open it for you to be able to see. If I can open it. Come on, open up here. Why are you using that problem? Reason number 1, use the problem to introduce a new concept. So maybe that was your 3rd grade teacher's, where she was. So in that case, it's gonna probably not do well. They're not gonna get it, they're gonna be struggling around there. Productive struggle is another reason you might choose a particular problem. And then problem completion. So if her mind was in, I want kids to get completing the problem and getting to that correct solution, then yes, she's gonna feel very frustrated because they may not be there at that problem completion stage. And then this blog, I like it not only for those 3 reasons, but he says, people who come in and see what's going on may not understand if they think that you should be getting kids to that problem completion, but your goal is either introducing a concept or allowing them productive struggle, then you might have this kind of going on where if your principal or someone else comes in going, they did terrible, or if she has in her mind that I need to get them there. Anyway, highly recommend Robert Kaplinsky blog if you're into math like I am into math. And he just sends them every once in a while. They're not long. This is 3 pages long. So
Well, I think with that specific teacher, what you just said, she was worried that it's her job to get them there, and that's part of our job, but it's not the only part. And I think that allowing kids to think has kind of gone by the wayside. Like we teach them how to do something, I do, we do, you do, kind of a deal, and then, but it doesn't give them a chance to struggle with it. And one of the things she said in here, that was on page, says, children not only need to learn the big ideas in math, but also the mathematical ways of thinking that are entailed in generating these ideas, in deciding how to express them, and justifying that they are true, and in using them to justify the mathematical procedures they are learning. So they need to be taught how to be mathematicians, not just how to do math.
gosh,
Yeah.
I think you and I must have been.
Well, the same thing. Right, and so, obviously that's those 8 mathematical practices, and I was thinking, reflecting back in my own classroom, I had them posted on my wall, we talked about them a lot, we talked about mindset a lot, but even then, I don't think I did it justice, and if I could do it over again, half of the time would be centered around those 8 mathematical practices, and the other half of my time would be centered around the 69 math strands there are in 6th grade, not to mention all of the gaps that come through it, there's a lot. So and that's what you were saying, that those, that's how you get those mathematical practices, is let them struggle, do the rich tasks. And but that also popped a question in my mind. It's like, if this is the research and this is how we're moving, why is it that they're adopting a curriculum? Because I feel like it goes against everything.
I've had that conversation a lot with, especially teachers who are using cognitively guided instruction as their Bible, and they're using it extensively in their math program, and they're fearful about what's going to happen with this math adoption.
That problem that I told you about today, the division class in 5th grade, that was straight out of the textbook. Yeah, so it's like, Anyways, go ahead.
So maybe we can just get good at seeing that and then popping it out.
Yeah.
Well, and that's what
You know
I
what I
said,
mean?
that's my,
Yes.
my feeling is if
Yeah.
if I can reach critical mass across the district about, really truly how kids think about math and how we can best support them in that, it doesn't matter what curriculum, what materials we use, we can tweak and use that critical eye when we're looking at the materials. Because those people are not down in the trenches, and they may not be up on the latest understanding about what a 7-year-old understands about math, for instance. So I want to reassure people that maybe you're feeling that way, that it'll be okay. But we need to have that sense of ownership and empowerment of, in our own minds around what it means to understand and do mathematics. And therefore, when I'm with children, I'm going to make sure that they have those experiences that will empower them. So I'll get off my soapbox now.
She'll
Well, I mean,
get back
there's
on it
something
though.
to it.
Yeah, I will.
How many times do you say, "Okay, get out your math books," and the kids are like, "Yay!" Because I always heard, I don't want to do that. It's like, you don't even know what we're doing today. But just because I said, "Get out your math books," all of a sudden they're just like, okay.
Well, you know what's
because
funny
that's
is-
not real math.
Yeah.
That's not what mathematics really is, and so they recognize that on some level. This is artificial, and it doesn't feel real, and it doesn't feel like it's a real application problem. On the other hand, when they have those experiences, kids will say, "I love math," you know, it's, "Yay, we get to do math," or "Do we have to stop?" I mean, seriously, you will
Yeah.
hear those conversations or those statements being made when you're tapping into that true math. And I love CMP. I mean, what you were using in math, CMP problems are great. But there's something about get out your book that is not, they're not making that connection to real.
What's funny about the books, though, real funny, that my kids happen to say just today. This is, "Bar, how come we never use the math books? Since you," because they're the trick books. And we do a lot in our math journals. We do a lot hands-on.
Right.
We do a lot on the boards. I've had parents say, "Well, how come they're not bringing home a math sheet every
Yeah.
day?"
Yes.
Because
I
we don't do that. But it is funny. Just today, they actually asked for the math books. And I thought that was funny because I've never had that, where they were like, and so I should have questioned more, which is my goal, to question more even with the kids, but I laughed at that and I thought I should have asked them more why. And my guess is what we're doing now is harder than what's in those books. That's my guess. They would prefer to fill in the number,
Excuse me a minute. Can I help you? Oh, he's in the right spot. Must be Tony's kid. That reminded me, one of the teachers in first grade this is how she teaches anymore. And she actually had a little girl ask her, "When are we gonna do that other math?"
Yeah.
And she said, "What do you mean, that other math?"
That's it, Mom. They're sitting in the back of the room. They said,
Yeah, so anyway, it's just kind of interesting. There are just a few minutes left, and I would like to show you this video clip on equality from the book, and you have access to, can I borrow that book for a minute?
Yeah.
You have access to all the video clips, if it says here in this little box on the front cover that includes downloadable resources. Mine, my copy is pre your copy. I got a CD. But you guys so on Roman numeral page 12, also in actually it's on the contents page. That's the first place you'll find it. That gray box at the bottom of the page tells you how to access the video clips yourself. And there are not that many of them, but this one I want to show you is about 10 minutes long, so I would like to dive into it. It's an older class, probably maybe 5th grade-ish, and how she deals with the kids' misconceptions around the equal sign, so.
I want you to think about what number would fit in the box. Okay? So I'm gonna give you this number. Think about it for a second and think what number goes in the box. I see some people really thinking of some strategies. Got 4 people who know it, 5, 6 know it, 7, 8, 9, 10, 11 people know it, 12, 13, 14. I think everybody knows it. Okay, let's see what you got. Let's see what you got. What do you think? 12? Okay, we think 12. What's another answer? Anybody have another answer? Like another idea? How many people think it's 12? Okay, so we're going to put 12 in the box.
I don't know what
Let me
yours
ask
was
you
done.
this. We're going to come back to that one in a second and we're going to double check it. All right? Let's go to another one. Ready? Was that pretty easy? All right, here we go. Is that true or false? ¿Es verdad o falso? Or no es verdad? Is that true or is that false? Yeah. Is it true that 7 equals 3 plus 4? Samuel, what do you think? It's backwards? What's wrong with it? It should be 3 plus 4 equals 7. Would that be right? So this is not right? Why not? Oh, you just can't understand it like this? And so is 7 equal to 7? Does 7 equal 7? No? 7 does not equal 7? Okay, let me ask you this one. Let me take you to another one. True or false? 6 equals 6 plus 0. Is that true? Is it true that 6 is equal to 6 plus 0? Talk to each other. You guys can talk to each other if you're not sure. No es verdad. 6 es igual a 6 más 0 o no es verdad. ¿Falso o verdad? Hablen ustedes tres. Ooh, I got a lot of people that have it. A couple people are still talking over here. Let's give them a second. ¿Están listas? Okay. Here we go. What do you think? Eric, what do you think? Falso? Why?
Porque no se puede contar así.
You can't count like that? Why not?
Porque cómo va a ser 6 más 0.
Dímelo otra vez.
Porque cómo va a ser 6 más 0.
So you're saying, how can that be? And it can't be? Okay, what else do you guys think?
It's true.
You think it's true? Why?
Because 6 equals 6 is 6. 6 plus 0 is 6.
6 plus 0 is 6. And 6 equals 6. Do you think it's true that 6 equals 6? Let's do it over here. 6 equals 6. Is that true?
Yes.
Does 6 equal 6?
Yes.
Ah, what about this? Does 5 equal 5? How many people think 5 equals 5? How many people think 6 equals 6? How about 10? Does 10 equal 10? How about this? Does, if 5 equals 5, does 5 equal 4 plus 1? Why? Because this is still the, it's still 5. So is it the same on both sides? Okay, so difference to both sides?
Like 6.
Are they the same?
Yes.
They're both the same? So 3 plus 3 is the same as 6? Because what is this equal?
6.
6. So let's go back up here then. So you told me that 6 equals 6, 5 equals 5, 5 equals 4 plus 1. Does it matter if I write it like this
No.
or like this?
No. It's still the same.
It's still the same, right? Because what is this?
5.
5. So this is still 5 equals 5, right?
Yeah.
So it's still coming out the same. So let me take you to this one again. I want you to talk to your partners. A little while ago you told me 8 plus 4 equals the same as 12 plus 5. Talk to your partners and see if you still agree with that. Talk to each other. See what do you think? If you agree, why do you agree? If you do not agree, what would you put in that box to make it true? What would you put in the box to make it true? Talk to each other. What do you guys think? 1.
8 más 4 pero aquí tengo ahora 9.
So why did you have to make that? Why did you have to make that? Okay. Alright, are you guys ready to share? You're not ready? I'll give you a few more seconds. You guys ready? How many people think that we should leave the 12 there? Do you think we should leave the 12 there? No. Why not? Why can't we leave the 12? Let's start with that. Why can't I leave the 12 there?
Because 12 plus 5 doesn't equal 12.
Okay, 12 plus 5 equals how much?
17.
And that does not equal what?
12.
Where'd you get the 12 from?
8 plus 4.
So that does not equal 12. So what do we need to do, Yvette? ¿Qué tenemos que hacer?
Okay.
¿Qué vas a hacer?
8 más 4 son 12.
Okay.
Y 5 más 7 son 12.
Okay, so ¿quieres cambiar aquí? ¿Son cuántos?
12.
So now are they the same?
Yes.
Is that true?
Yes.
So now are both sides the same?
Yeah.
Yeah, now they're equal. Okay, good. Are you ready? One more.
Yes.
Oh, cool. Hear that?
Go. Okay, así que 10 y 9. Let's see what we got. What did you guys get? You got 19 going in the box? People told me 19. But is 19 the number that goes in the box?
No.
You have to be super duper duper careful of what you are saying. You're gonna put what in the box? 8. Now, why are you gonna put 8 in the box? Why did you decide to put? Okay, because 11 plus 8 is 19. Why were you trying to make 19 over here? and that over there. Why?
But the 19 is the same one like 15 times 4.
15 plus 4 is also 19. Is 19 equal to 19?
Yes.
Dog.
I like that video because she deals with all of those conceptions that kids have, and how she uses that number talk and that 10, I don't know how long it was. It's a 10-minute video, and I'm sure it took her probably a whole class period to get there, but they now have a much stronger sense of what the equal sign means from her taking that time, and they own it more than if the teacher just says, well, they have to be the same on both sides. They own it now. They have that justification. She was pressing on them for that justification. How do you know? Why is it that way? So it's 5:30 now, so we're gonna call an end to our day today, but if you look on page 24, there are some challenges at the end of each chapter now, beginning with chapter 2. And I would encourage you, as you're doing your reading, to look at those challenges and try out some of them with your students. And then feel free to bring student work with you. So if I would ask you to look at challenge 4 and 5 on page 24. Try to do those before next meeting. And then if you turn to, we're going to read next time chapters 3 and 4. So take a look at those challenges as well, and see if there's some there that you'd like to try out too, and bring that student work back with you. So thanks for your good discussion tonight. I'm sorry we didn't get through our whole protocol, but it was good discussion what we were able to cover. So thank you. And
Thank you.
yes. We'll turn the video camera off.
But you have yours and too. The one